Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on August 19, 2025, just yesterday. The standout result is that the model hits a 56.2% zero-shot success rate in simpler ENV and 87.5% across 8 real-world XARM tasks, a roughly 62% improvement over strong baselines. The paper is titled Embodied-R1, Reinforced Embodied Reasoning for General Robotic Manipulation. And as we will see later, the implications for robot generalization are quite significant. In short, the work uses pointing as a universal bridge, from vision language understanding to reliable manipulation across embodiments. Also, the authors shared an official GitHub repo. You will find a README with setup steps, conda environment and pip requirements, Docker files, and a makefile. There are assets, eval scripts for benchmarks, and early scripts and library code. Pre-trained models and datasets are linked, while full training and inference code are noted as coming soon. Alright, this figure lays out the whole pipeline and evaluation at a glance. On the left, the model reads an instruction and image, reasons step by step, and outputs a point or visual trace that the action executor can follow, which matters because the same trace works across different robots. The top right radar highlights stronger scores across spatial and pointing benchmarks. Along the bottom, you can see pointing evaluations, zero-shot robot tasks, and robustness tests under lighting, background, and height shifts. Building on that, this figure shows how a single instruction flows into 4 pointing abilities that anchor action. On the left, the system reads the prompt and thinks before outputting points or a trace. The center panels illustrate referring expression grounding and region reference grounding, which select the object and the target area. To the right, object functional grounding highlights grasp points, while visual trace generation draws a trajectory the executor can follow. Alright, this table compares spatial reasoning across 5 benchmark suites, and it highlights averages and ranks for both closed source and open source models. You can see the bottom row, Embodied-R1, topping the open source group with the best average scores across CV-Bench, CRPE, SAT, BLINK, and EMB spatial, which matters because these cover counting, 3D relations, subject-object relations, and relative depth. Notably, common sense data helps, since the without common sense variant ranks lower. Trigger text. Alright, this table compares bounding box 0.02, 0.10, 0.98, 0.95. Next, this table summarizes pointing and manipulation outcomes across several benchmarks, so you can see where the gains come from. The upper block lists end-to-end vision language actions, which trail on average success, while the middle modular block improves because perception and planning are separated. The bottom affordance block highlights the key result. Embodied-R1 leads with higher grasp and final success, reaching a 56.2% average. The rightmost average column makes the margin clear across tasks. Wrapping up, 2 takeaways stand out. Pointing as an embodiment-agnostic bridge turns language into precise, transferable action targets, and reinforced fine-tuning with task-aware rewards delivers real gains, with strong spatial reasoning and zero-shot manipulation success. Together, these choices narrow the seeing to doing gap. Thanks for listening. I'm Alex, signing off.